Hi, good afternoon, everyone. I hope you guys are doing fine. So today we will be looking at some problems on series. Okay, so let me just quickly give you guys a short reminder of what we've been working with so far. We talked about sequences, right? So if I ask you, when do you know if a sequence converges or diverges? What would you do in that case? How would you determine if a sequence should converge or diverge? What would you do? You take the limit, right? You just take the limit at which n goes to infinity. And if it gives you a finite value, then it converges. And if it gives you an infinite value, then it's what diverges, right? So yeah, so now we want to talk about series, okay? Series is just the addition of sequences, right? So let's say you're given a sequence and you had the terms, let's say from n starting from 1 to infinity, then that's series, okay? So that's the addition of the terms of sequence. Then there's something called partial sum. Partial sum is when you had the first nth term of the sequences, okay? For example, if I have A1, A2 up to AN, then I have the partial sum. Does that make sense? Then we say that a series converges if the partial sum converges, okay? If the partial sum, when you take the limit at which n goes to infinity, if the partial sum converges, that means the series what converges. Does it make sense? All right, so so that leads us to the first set of problems. That is something called the telescoping series. And let's look at the first example for me to be able to explain to you what telescoping series means. Now, if you look at this first example, you're given the summation from n starting from 4 of this sequence here. The sequence here, so I'm starting with problem A, right? So you have the summation from n starting from 4 till infinity of 1 divided by square root of n minus 1 divided by square root of n plus 1, right? Do you see that? Now, let me call this my sequence an, right? Let me call this my an. So don't forget that I said that series is just summation of sequences, right? So my sequence here is 1 over square root of n minus 1 over square root of n plus 1, right? Do you see that? Now, I want to find the nth partial sum. How do I find the nth partial sum, right? First of all, I try to find what are the values for A4 because n is starting from 4, right? Don't forget that your partial sum Sn is just the summation of A1, A2, A3, A4 up to what? An, right? But because this is starting from 4, so this is going to be A4, A5, A6 up to what? An. All right, so let's write the first term. A1. A4. Okay, so A4 here is what? 1 divided by square root of 4, right? Minus 1 divided by square root of 5. Do you see that? Mm-hmm. What of A6? A6 is what? Sorry, A5. Okay, so A5 is 1 divided by square root of 5 minus 1 divided by square root of 6. How about A6? A6 is 1 divided by square root of 6 minus 1 divided by square root of 7. Then A7 is 1 divided by square root of 7 minus 1 divided by square root of 8. All right, so let me stop here. Then let me move on to AN. AN is what? Just 1 divided by square root of n minus 1 divided by square root of n plus 1. Can you see? All right, now, so to have a better picture, let me write AN minus 1. AN minus 1 is just replace, like anywhere you see n, replace it with n minus 1. And you have this with square root of n. All right, don't forget that your partial sum is the additions of A4, A5, A6 up to what? AN, right? But when you observe, what would you, if you look at this set of A4, A5, you notice something that I have negative 1 over 5, then I have plus 1 over 5, I have negative 1 over 6, and I have plus 1 over 6, right? If I should add all those terms together. Do you see that? So you notice something that this takes care of this. If you add this and this, you have 0. If you add this and this, you add what? 0. If you add this and this together, you add 0. If you add this and this, you add 0. That means if I add this and this, I'll have 0. And if I add this and this together, I'm going to have 0. That means that my Sn, right, if I should add all these terms together, the only terms that is going to be left out is going to be 1 divided by square root of 4 minus 1 divided by square root of n plus 1. Sorry, this is 4. Okay, this is the partial sum. Now, how do I determine if the sequence, if the series converges? What am I going to do next to determine if the series converges? Anyone? Oh, thank you. Take the limit. So let's do the take the limit of n goes to infinity of Sn. So what is the limit, guys? That's the limit at which n goes to infinity of 1 divided by square root of 4 minus 1 divided by square root of n plus 1, right? Do you understand? Does it make sense? So if you take the limit at which n goes to infinity, what are you going to have? What do you say? 1 half. Why?
Because n plus 1 will infinitesimally be big.
Big, good.
And
then
we're actually going to 0.
0, good, that's good. So this is going to 0, and this is just going to you're just going to have square root of 1 over 4, which is just 2. 1b is what? Is that you should find the sum starting from 2 to the infinity divided by 2n squared minus 1, right? I mean, it's not quite obvious how this is going to be like a telescoping series, right? It's not quite obvious, but we can try to use partial fraction, right? Let's try to use partial fraction for 2 divided by n squared minus 1. You remember that this is still the same thing as 2 divided by n minus 1 multiplied by n plus 1, right? Do you guys agree with me? Right? Difference of 2 squared. And this is, to resolve into partial fraction, we say this is a divided by n minus 1, then plus b divided by n plus 1. Should I leave you guys to solve for a and b, or we should do it together? Or does it? Okay, let's just do it together. So that means that we're going to have this to be 2, as in, normally what we are doing here is that we are to find the LCM of these two denominator here, which is just n minus 1 multiplied by n plus 1, right? So if I divide this, that means I'm going to have this to be a multiplied by n plus 1, then plus b multiplied by n minus 1, okay? Then I have this to be exactly what I have on the left-hand side, which is just 2 divided by n minus 1 multiplied by n plus 1, right? Because they have the same denominator, right? So this can take care of this, right? I can cancel it out. Then I'm going to have what? I'm going to have this to be 2 to be equals to a n minus plus 1, then plus b, right? Multiplied by n minus 1, okay? So now how do I find my a and b? So all I need to do is just to say when n is -1 and when n is 1. Why am I using that approach? Because why? Because the denominator here are just product of 2 linear terms, right? I only have product of all these terms here are linear, right? This is linear, and this also is also linear. So these are linear and these are linear. So I can use that idea of setting this to 0 and finding n. So when n is -1, that means I'm going to have this to be 2. If n is -1, that means this is going to be -1 plus 1, which is just 0. That means I'm going to have this to be negative 2b, okay? So if you substitute n to be -1, so you have -1, which is just -2, okay? Do you see that? Right? Okay, so that means that b is -1. So then again, I would say when n is what? 1, that means I'm going to have this to be 2 multiplied by a 2a. That means that what a is what? 1. So that means that this summation here can be written as a, which is just 1 divided by n minus 1, then minus 1 divided by n plus 1. So that means that, so you have an to be 1 over n minus 1 minus 1 over n plus 1. So our job is to find the partial sum, right? Now if you look at the summation is starting from where? 2. That means that my partial sum is going to be, my Sn is going to be a2 plus a3 plus A4 plus up towards AN, right? So for me to find the partial sum, right, I need to list out the A1, A2, A3. You understand what I'm trying to say? Then I can now see how the terms cancel out. I will need to study the pattern. So let's list out A2. A2 means that anywhere you see N, substitute 2 in this expression over here. All right. So that means if I do that, A2 is going to be 1 over 1 minus 1 divided by 3, right? Then what of A3 is 1 divided by 2 minus 1 divided by what? 4. What of A4? A4 is 1 divided by 3 minus 1 divided by what? 5. Okay? Do you see that? What of A5? A5 is what? 1 divided by what? 4 minus 1 divided by what? 6, right? How about A6? A6 is what? 1 divided by 5 minus 1 divided by 7. All right. So let's go on up to let's go on up to AN. So AN is what? 1 divided by N minus 1 minus 1 divided by N plus 1. How about AN minus 1? AN minus 1 is what? 1 divided by what? N minus 2, then minus 1 divided by N, right? Now how about AN minus 2? AN minus 2 is what? 1 divided by N minus 3 minus 1 divided by N minus what? N minus 1. Do you see that? Do you see that? Do you guys see? I just try to write, okay, this is my AN minus 1, that's the 10 before it. Then what about AN minus 2? That's the previous, or the, I don't know, the previous of the previous 10. All right? So now the point I'm trying, why am I writing all these things out? The point is that I want to study the pattern. I know that some things are going to cancel out each other, or I need to study how those terms are canceling out each other. Now look at it. You see that I'm having negative 1 over 3 here, right? So before I can have positive 1 over 3, I need to go 2 steps. That's 1, 2, right? Then I see positive 1 over 3. That means this is canceling out this. Do you see that? Right? Now, for me to have, look at now, let's say I want to cancel out negative 1 over 4, right? That means I need to go 2 steps, right? That means 1, 2. Oh, that means I need to cancel out this, right? So I have, this is negative 1 over 4. Then for me to cancel out positive 1 over 4, for you to cancel out with positive 1 over 4, that means I need to go 2 steps. That's what? 1, 2. Then I cancel out this. So let's, use this pattern to cancel out the terms that is not needed and see the remaining terms. All right. What is the idea behind the canceling out? Canceling out is in the sense that because I'm having positive and I'm also having negative, so something is going to cancel out. All right. Does that make sense? So that means that here, this is going to cancel out this, right? This is going to cancel out. I need to go to steps 1, 1, 2. That means this is canceling out this. Then minus 1 over 5 is going to get cancelled out by this. Then minus 1 over 6 is going to get cancelled out by this. Technically not by this, but this is going to get cancelled out at the end. And this is also going to get cancelled out at the end. All right? All right, so let me go back again. Let me go back again from negative 1 over 6. Negative 1 over 6 is going to get cancelled out eventually, right? Negative 1 over 7 is also going to get cancelled out eventually. This is also going to get cancelled out eventually. And also this is also going to get cancelled out eventually. Well, it's not quite obvious. Let me go again. So what I'm going to do is that let me try to bring this down a little bit. Okay. All right. So yeah, let's do that again. All right. So negative 1 over 6 is going to get cancelled out by something here, right? Because I only need to go 2 steps down, right? That's 1, 2. That means it's going to get cancelled out here. Then negative 1 over 7 is also going to get cancelled out by going 2 steps. That's 1, 2. That means something here, right? Then at the end, this is going to get cancelled out by this, and this is also going to get cancelled out by this. So, and here you can see that negative 1 over n, and I also have positive 1 over n. So eventually, I'm going to end up having my Sn to be what? So what are the values remaining? I'm going to have 1 divided by 1 plus 1 divided by 2 minus 1 divided by n from here, right? Then minus 1 divided by n plus 1. So that means for us to find the sum of the sequence, what are we going to do? We take the limit at which what n goes towards infinity, right? So what are we going to have eventually? Of 1 plus 1 over 2 minus 1 over n minus 1 over n plus 1. So what are we going to have, guys? This is going to 0 and this is also going to 0. So what are we going to have? 3/2. So the limit, the sum of this series is what? 3/2. All right, so let's move on to the next problem. Right, so here is the next problem, right? So they said evaluate the sum of the series where the partial sum is given as this. So, right, so look at this question. I want everybody to do this question. It says evaluate the sum of the series. So you're given the partial sum of the series to be 4. The partial sum is given as 4/7/29 to the power of n. Now the question for you is to find summation of n to infinity of an. So now this is what, now who can tell me what is this limit? If you take the limit at which n goes to infinity, what is the limit? 0, right? Why is it 0? We are going to talk about it. No, I think we've talked about it before, right? Why is it 0? It is 0 because I remember giving you this formula. That is, if you have r limit at which n goes to infinity of r to the power of n, this is going to go to 0 if the absolute value of r is less than 1. And this is 1 if r is what? 1. And this is what diverges, right? If your absolute value of r is greater than 1. If this value of r, if you take the absolute value and it is more than 1, it's going to diverge. If it is less than 1, it's going to what? Converge. If it is 1, it's going to be 1, right? Now look at this limit here. Limit at which n goes to infinity of 4 multiplied by 7 divided by 29 raised to the power of n, right? Here, if you look at it, you can think of r. 4 is just a constant, so you can pull it out, right? Then you are all left with this, right? So this is my r here, right? This looks so much like my r, right? So my r here is what? 7/29, which is far less than 1, right? It's less than 1. So that was how we ended up having this converging towards to 0, right? So so that means that the summation of this series is what? 0, right? Do you understand? So let's move on to this following set of problems. That's the geometric series. Okay, geometric series, all right? Geometric series are always of this form. That is, if you have a, of course, you learn about geometric sequence. Now geometric series is like you're adding AR plus AR2 plus AR, 3 up till what? Infinity. So the general way of writing this is n starting from 1 till infinity of AR n minus 1. Do you see that? Right? And this converges to a over 1 minus r if and only if your absolute value of r is less than 1. Okay, this r is called the common ratio and your a is called the first term. All right, I mean in high school, we call it a as first term and r as common ratio. Right? Another way of writing this summation, is by saying that, okay, n starting from 0 to infinity of AR to the power of n. I'm claiming that this expression here and this expression here are the same thing. Don't take my word for it. Let's look at it. If n is 1, right? If you put n to be 1, so what are you going to have here? You're going to have, if n is 1, you're going to have what? You're going to have a r 1 minus 1, which is what? Just a, right? Because r raised to the power 0 is what? 1. Now let's try to do for this. Let's try the first term for this this summation here. All right. If n is 0, what are you going to have? You're going to have AR to the power of 0, which is just going to be what? A is still A, right? I mean, A times R to the power of 0 is still A, right? Now, you see that they have the same first step. Okay, so let's put n to be 2 because summation is like moving from first counter to the next counter. So the argument here is that this is going to generate the following sequence. It's going to generate you're going to have AR0, AR1, right, plus AR1, plus AR2, plus AR3, right, up till what? Infinity. And this is going to generate AR0 because you are putting 0 here. This is 1 minus 1, right? This is 2 minus 1. This is 3 minus 1. This is 4 minus 1. I know I'm oversimplifying things, but I just want you guys to like get understand why this expression here is. Just get convinced why this expression here is equals to this expression, AR1. So that means technically this expression here is the same thing as this expression. That is if I should add all the terms here together. But because you are going to infinity, it doesn't make any difference. All right? It doesn't make any difference. Okay? Infinity is like a large number. I mean, it's like really a large number. Okay? So you agree with me that this expression here is the same thing as this expression here, right? All right, so this means this is going to be A over 1 minus R. Okay, so that means, so I'm just telling you that depending on the question, you should know how to approach the problem. So let's look at the first problem. We're given summation of n starting from 0. And before I continue, I also like to point out something, all right? That anytime you're given you're asked to determine if a sequence, if you are asked to determine if a series diverges or converges, the first thing you might want to do is to carry out the divergence test. All right? What did I say? Divergence test, right? So what is your divergence test? Your divergence test says that if the limit at which n goes to infinity of your an, right, is not 0, right? If it's not 0, or if the limit does not exist or does not exist, you don't need to carry out any other test, right? Just conclude that this diverges. All right, just conclude that the series what diverges. That's the meaning of divergence test. If the limit is not 0 or does not exist, that means that what the series what diverges. Does that make sense? All right, let's come back to our question. Now look at this expression here. Minus 5 to the power of n, right? Then divided by 6 to the power of n plus 1. Now look at this. Notice that the counter here is starting from 0. That means I want to use this version of geometric series. All right? So that means I need to write it as AR to the power of n. All right? So how do I do that? I look at it. This is summation from n starting from what? 0 to infinity. And this is minus 5 to the power of n divided by, now what is 6 to the power of n plus 1? 6 to the power of n plus 1 is still the same thing as 6 to the power of n multiplied by 6, right? Because they have the same basis, right? And if you had n plus 1, because, I'm just trying to use this fundamental law of indices that if you have a to the power of b times a to the power of c, this is a to the power of b plus c. Do you guys get that? So that is why I have this to be, 6 to the power of n times, times 6. All right, so let's come back to our problem. So this can be written as summation from n starting from 0 to infinity of 1 divided by 6 multiplied by minus 5 divided by 6 all to the power of n, right? You see that I've regrouped it to have everything all to the power of n. Do you guys understand? Now you can see that this looks so much like, this expression here looks so much like this expression. How? My a is what? 1 over 6. Just take a to be 1 over 6 and take your r to be what? Negative 5 over what? 6. Make sense? Now, the question is that, does this series converges? We don't know. Let's take the absolute value. Let's take the absolute value of this. The absolute value of this is what? Less than 1, right? That means it's what? It's what converges, right? What does it converge? It converges, right? Now, since we know that if the absolute value of r is less than 1, it converges, now let's now determine the sum right? Because one question they will always ask you is that, okay, if it converges, find the sum. So to find the sum, all you need to do is just to use this expression over here, right? Sum to infinity, which is just what your first term, which is 1 over 6, divided by 1 minus your common ratio, which is minus 5 over 6, right? And if we should simplify this expression over here, we're going to have 1 divided by 6 divided by 11 divided by 6, because 1 plus 5 over 6 is 11 over 6, and which you end up having 1 over 11. 1 over 3 to the power of this can still be written as 1 divided by 3 all to the power of n minus 1, right? Because you have 1. 1 is like an identity factor, so you can always raise it to the power of n minus 1. So that means I can just bring out n minus 1 from that. I can just rewrite it this way. All right. Do you agree with me with that? This expression here is still the same thing as expression here, right? So what do you observe? That 1 can still multiply this, right? So if you have summation, you have summation from n starting from 1, of n starting from 1 of 1 times 1 over 3 raised to the power of n minus 1. All right. Now you can see that this looks so much like this, right? Because n is starting from 1. So I'm trying to use this and this expression over together, right? So that means, what is my a? Can tell me. My a is what? 1, right?
Yeah.
Do you see that? No, my a is 1 because this is 1 is the one coming out.
Oh, yeah.
My r is now 1/3, right? So you can see that if you take the absolute value of r is less than 1, you can conclude that it's what converges, right? Now, what does it converge? Now, if it converges, now what is now the sum of this series? You can now use this expression over here, which is just a, that's 1 divided by 1 minus 2 over 3, which because your r is 1 over 3 rather. And I'm sure that this is going to be 3 over 2. So problem C is summation from n starting from 1 till what infinity of minus 3 to the power of n divided by 2 to the power of n minus 1. All right. So does it converge or diverge? So to see that, we have n starting from 1 to infinity, because my n is starting from 1. So I want to have a r n minus 1 because r is starting from 1. Okay. So that means I can have this to be minus 3 to the power of n minus 1. And all I need to do is just to multiply by negative 3. Okay? Because why? Because minus 3 raised to the power minus 1 times minus 3 is just 1. Okay? So that was why I have this expression. So I'm trying to convince you that this expression here is still the same thing as 2 raised to the power n minus 1. Okay? So whereby you can now have this to be summation of n starting from 1 till infinity of minus 3, right? Then you now have negative 3 over 2 to the power of what? N minus 1. What is my a? My a is what? Negative 3. And my r is what? Negative 3 over 2. If you take the absolute value of this, what are you going to have? Is it going to be less than 1? It's going to be greater than 1. So what can you conclude about this series? Diverges, right? Good. So let's do problem D. Problem D says that n starting from 1 till infinity of 3n squared plus n divided by n squared plus what? Plus 4n. All right. Now this doesn't look like geometric series, right? It doesn't look like geometric series, does it? No. So I might be tempted to try divergence test, right? If something doesn't look like what I know, I might just want to try divergence test, right? Remember divergence test. Divergence test says that if you take the limit at which n goes to infinity of 3n squared plus n divided by n squared plus 4n, what is this going to give you? All right. How do we find the limit? Guys, just factorize the highest power. Highest power is n squared. That means I'm going to have 3 plus 3, 1 over what? N, right? If you expand this numerator out, 3 times n squared will give you this, and to give us that. Then if you factorize this, that means we are going to have 1 plus 4 over n. This cancel out this, then that means that I'm left with limits at which n goes to infinity of 3 plus 1 over n divided by 1 plus 4 over n. If you take limits, this goes to 0, this goes to 0, that means we're going to have this to be 3 divided by 1, which is what, 3. This is not 0, right? So what can you say about this series? Divergence test. It says that if the limit, divergence test says that if the limit is not 0, right? Let me show you divergence test. It's there in your notes, but let me show you. This is the divergence test. Right? Do you see that? If the limits of your sequence, like this is your series, this is the series you want to determine converges or diverges. If the limit is not 0 or does not exist, then this series what diverges, is divergent. Do you see that? Make sense? Do you see that? So you now see that, okay, let's go back to the problem we're trying to solve. You see that this is not 0, right? So we concluded using divergence test that this is not what? It's not convergent, which is divergent, right? All right, so let's move on to the fourth problem. The fourth problem in less than a few minutes, all right? It says determine whether this sequence converges or divergent. So the first question is that we should determine whether this sequence converges. So you're given, so for me to determine if the sequence converges, all I need to do is just to take the limit, all right? Limit at which n goes to infinity of n squared plus 4n plus what, 8 divided by 5n squared plus 5, right? Then for this, because here, to take the limit of rational function, all you need to do sometimes is just to factorize the highest power, right? The highest power here is n squared, so I bring out n squared from the numerator, which is going to be having 1 plus 4 over n plus 8 divided by n squared. Then if you factorize n squared at the denominator also, that means you're going to have this to be 5 plus what, 5 over what, n squared, right? So you see that this cancels out this. And if I should take the limits at which n goes to infinity, this goes to what? 0, this goes to 0, and this also goes to 0. Eventually, this goes to what? 1 over what? 5, right? So is the sequence convergent or divergent? Does sequence converges or diverges? Converge is good because convergent of sequence is quite, not so much rigorous. Take the limit. If the limit gives you a finite value, then it converges. If it gives you an infinite value, then it diverges. So therefore, this is convergent. Does it make sense? Huh? Thank you. So now the next question is that now determine if the series converges. What can you conclude from here without doing anything? What can you conclude? Is the series convergent? Does it converge? In less than 1 minute, guys. Does it converge? Guys, you know the answer. Tell me.
Would it be divergent because
of divergence test? Yeah, that's correct. Yeah, that's what I'm looking for. Because when you take the limit of the sequence, and it's not 0, right? Minus 1 over 5 is not 0, right? That means it's divergent by divergence test. So B, since the limit at which n goes to infinity of your an is not 0, then by divergence test, n starting from 1 to infinity of an is divergent. Question, again, is that is the sequence converges? Like determine whether the sequence Bn, given as 3 divided by 7 up to the power of n, does it converge? Does this sequence converge? Don't forget that there's a difference between sequence and series, right? Sequence, take the limit at which n goes to infinity. If it converges, boom, fine. If it gives you a finite value, it converges. If it gives you an infinite value, it diverges, right? But for series, there's something called divergence test. If you take this if you take the limit of of the sequence, right? Don't forget that series is just the summation of sequences, right? As any, from 1 to infinity, or sometimes from any value to infinity, right? The point is that the convergence or the divergence of a series is quite rigorous. You can't just conclude, right? You can conclude it is divergent if it obeys the law of divergence, if it satisfies the divergence test hypothesis. That is, if the limit of the sequence is not 0, then diverges. Okay, so let's do this. Does this sequence converge? So let's take the limit at which n goes to infinity of 3 over 4, 3 over 7 to the power of n, right? So this converges to what? 0, right? Because because I gave you this, you remember this this sequence here, that this converges to 0 if the absolute value of r is less than 1. This converges to 1 if r is 1, and is divergent if the absolute value of r is greater than 1. Do you guys remember? Please don't forget this expression here. It's very important. You use it a lot, okay? And you'll notice that my r here is just 3 divided by 7, right? If you take the absolute value, this is less than 1, right? That means it converges to 0, right? So that means the sequence is what? Convergent. Do you understand? Now the question to you is that determine whether the series, right? The series which sequence is Bn converges. Now you don't want to use divergence test. Why? Because divergence test only applies when the limit of the sequence is not 0, right? It only applies when it is not 0 or when the limit does not exist. But the question to you is that what is the limit of this sequence here? The limit of this sequence here is 0. That means we cannot use what? Divergence test. Do you see why we cannot use divergence test? That means we now need to investigate further, or we cannot try out other methods of finding convergence or divergence of sequence. So we have less than 1 minute. So here we have n starting from 1 to infinity of, starting from 0 to infinity of what? 3 divided by 7 up to the power of n. So my a is what? 1, and my r is what? 3 over what? 7, right? That means this is going to converge to what? Of course, the absolute value of r is less than 1. That means this is what? Convergent, right? Do you see that? And what does it converge to? This converges to what? 1 divided by 1 minus 3 over 7, and which is what? 1 minus 4 over 7, which is what? 7 divided by 4, right? And we are done.